Yes, sir.
But what we are gaining because of reduction in voltage gain? Two things we are gaining. What are two things we are gaining because of this drawback? One is the current gain is increasing because my input current is less. Second thing, my stability is improved. When you focus that's what we say. You have to have a trade-off between gain and stability. If you want more gain, you have to compromise on stability. You should not worry about stability. If you want more stability, you have to compromise on gain. You cannot have an amplifier which has a very high voltage gain and very high level of stability. That is practically impossible. So when you have a very high level of voltage, when you have a very high level of stability, you have to be compromising on your voltage gain. There will be reduction in gain. Or if you want to have a very high level of voltage gain, you have to compromise on stability. So you cannot achieve 100% positive thing in both stability and voltage gain. That's what is given here. If you see, the addition of emitter resistance will reduce the voltage gain, but it will increase the input resistance. But this reduced value of voltage gain is not going to be a big concern for me, but it is going to improve the stability of my amplifier. Okay, so you have to look at all angles. Because of add just one resistance is added extra, right? See how that is impacting all the parameters of your circuit. So that is why these H parameters are very, very beautiful and important, and they make our analysis very, very simple. They clearly picturize which parameter of the transistor depends on what all resistance and H parameters. So from that relation, you can easily find out how the component is going to affect the circuit performance. Is this clear? Voltage gain? Any queries you can put it forth here. Maybe once you after the class, once you download and study, you will have a lot of clarity. I believe that. The last one is so see here, simplified model for simplified equation for voltage gain. So assume that the second term is very, very big. Denominator second term is very, very big. So I can write it as minus HFE into RL by 1 plus HFE into RE. 1 HFE and 1 plus HFE are going to be approximately same. If HFE is 100, 1 plus HFE will be 101. So I can almost cancel them. Almost, not exactly. So my voltage gain is approximately equal to minus RL by RE. See how this RE is impacting your voltage gain. So under normal considerations, a voltage gain is stable and independent of all transistor parameters except for RL and RE. The voltage gain depends on RL and RE. And understand both the resistance we are adding externally. So the externally added resistances are going to impact the performance of your circuit. Okay, please understand that the voltage gain in this type of bias, it is going to depend on RL and RE. RL is your resistance present at the collector side of your transistor, and RE is the resistance at the emitter side, and we have added this RE just to ensure the stability of my transistor. Okay, so greater the value of RE, the voltage gain will be less. When you don't have RE, the voltage gain will be maximum. Okay, this is a simplified expression for voltage gain. In all problems, whatever they ask, always go for the full standard formula for voltage gain. Don't use the approximate formulas unless otherwise specified in the question.